So thanks, Ori. And I think it was a great start. But really, my talk is, and we talked really in the previous session with the weights and biases, which is a product I really like, was really more focused on the training part. And I think most of the MLOps tools are focused on how to build or develop the model. But the real problem that most organizations face is not how to develop the model, is essentially how to plug the model into operational environments with production data, with real events and impacting real applications. And this is where a lot of automation is required. And I'm going to focus on that. I've seen some blogs or tweets before this session talking about, MLOps is take MLflow and stick it to Jenkins. But this is really, if you think that MLOps is about automating your training, you're right. But what we want to see is how to deliver applications or machine learning applications into production environment. And this is the goal of my talk. So most organizations, when you think about machine learning, it's very focused on the data science team lifecycle. So what do? You take some data, you take that data, you run some preparation in the notebook usually, you run some training using some, again, notebook code or some external service that does AutoML, you evaluate. The more advanced guys know how to take that model and put it behind some HTTP endpoint. But this is very focused on the life cycle of the data scientist and the data science team. But the real goal eventually is not to essentially go and build sort of a model, is to take that model and put it into an application that generates real business value. And that's not that simple. This is what you essentially need to do in a full production environment. You don't develop a model in Jupyter. You develop a model as part of an automated flow. We talked about CI in the previous session. We need to containerize the training jobs. We need testing, evaluation. We may want to compress models. We want to do automation and workflows that build all those things. And then we want to register the models in some registry. And this is just the first part. And if we need to scale, we need frameworks that know how to process data with the horizontal scaling or train data with horizontal scaling. Once we have a model, it's not just an endpoint, because essentially someone sends a JSON and someone needs to parse that JSON and validate the data and maybe take the user ID from that JSON and enrich it with data from a database and then do some scoring. And if you're more intelligent, you do some ensembles and you take those ensembles and you make some action. It's not just, okay, is it going to be a fraud, yes or no? I need to write it to a database. I need to notify a message queue. I need to block an account. So there are all sorts of things that we need to do as part of the real world application. We need to monitor all those activities in a very holistic view. If we do the training, we need to analyze the data sets of the training and compare them with the real world data from production and analyze things like anomalies, drift, accuracy problems, and so on. And finally, and last but not least, is the data processing. In order to generate any machine learning work, you need to analyze data, you need to aggregate and group and do one-hot encodings and all that. The easiest way is to take some CSV file or an Excel spreadsheet and stick it into the training, but that's not real life. Real life is the data sits in streams, in API endpoints, in databases. We need to grab it together. We need to join it together with point-in-time considerations. We need to analyze it in high scale. It's not like a 1 megabyte of CSV file. It could be terabytes that we need to analyze and do things like grouping and windowing and so on. So, and this data has to be versioning along the lines of training and serving and all of that. So that's a lot of work. That means that we have usually in organization different silos of people. We have the data engineers, the data ops, the MLOps, the data scientists, and all those arrows that you see in between are glue logic, things that someone needs to write and implement and test and create a technical depth around. So the real focus of MLOps is not really about automating the training, because that's a simple problem. The real problem that MLOps needs to solve is how to deliver this picture that you see here in a simple way. And we work in Iguazio. This is our core focus, is operationalized machine learning. And we came with a slightly different approach, and which I'm going to describe. We have an open source project called MLRun. You can go to mlrun.org. And we said, let's start with the end in mind. Let's understand, what do we need for production? How would a production pipeline look? And then build a development flow into that production, okay? So if we need to break the previous chart and say, let's build one continuous simple flow, we start with feature engineering. We need to take data from production, not from CSV files, okay? Maybe CSV files for some experimentation. We need to be able to take it, analyze it, group it, et cetera, do all sorts of transformation, and then serve that, catalog that data and serve it into the next steps in the flow, which is like training and serving and model analysis and explainability and so on. The next thing that we want to build is a fully automated flow that every time we create a snapshot of data. Why am I saying snapshot? Because if you have production data, you can't just use it all. You need to create a point in time, a snapshot of your data, run a full flow, which is not just training. It could be training, it could be testing, it could be deploying an endpoint, verifying that it works. It could be all sorts of things. Those workflows can be very complicated. We want to run this workflow. This workflow eventually generates a model object. This model object will go into not model serving, will go into an application pipeline. Because an application pipeline could include not just the model serving, could include, again, this parsing the JSON message and validating the data and doing the serving and doing some actions and maybe tracking some activities and measuring business metrics and so on. And we'll see at the end potentially few example applications. So we need to take that model into the pipeline, the real-time pipeline. We need to integrate with the online data, and we need to respond to user activities. But not only respond to user activities, we want to track everything that's going on, all the input data, all the output data, all the telemetry data, business metrics, and so on, and put them into a real-time analytics engine that knows how to make sense out of it, like analyze drift and analyze anomalies and so on, and write the production data from the user activities and everything back into the feature store. So the next time we retrain, we have a fresh data set to retrain on. So this is essentially what we've built as a fully automated flow, and we'll see that in a second, that allows us to essentially, without any glue, because all of those arrows that you see here, they all use common metadata. When I'm saying a model, it's not a model file, it's not pickle, it's a model object, which includes statistical information about the features, it includes schema of the features, it includes matrix and so on. Those things that allow me to pass an object and then in the serving side, just open the object, or in the monitoring side, verify that it actually behaves. So those are the things that we need to do. And then this engine has to speak to all the rest of the world. The rest of the world could be training frameworks or AutoML engines, could be CI/CD, could be Jenkins or GitHub, it could be managed notebook services or BI tools, etc. So it's very important to create an open ecosystem, open API to integrate with all the rest of the world and not keep it as a closed system. But it's very important to have the production side very integrated, very scalable, very high performance. And when you build each one of those components that's shown in the previous slide, there are lots of different steps. Don't think just about, okay, I'm writing some code, delivering it to production. You need to package it, you need to scale it, you need to tune it for performance, you need to automate it, you need to add observability. The best way to do all those work or those things without actually doing work is a concept not so new called serverless. And what we've done is essentially taken the concept of serverless into high performance analytic engines and machine learning engines that do all those things for you automatically. So instead of the traditional ritual of, I'm writing some code, giving it to the ML engineer to turn it into a Kubernetes piece of code, and then someone else will build a pipeline with data engineering and Jenkins and all of that, and then someone else will build the monitoring. We want to build a fully automated flow where you take the code, whether it's from the notebook or from your PyCharm, we automatically convert it into auto-scaling functions with auto-tracking and everything. We want to be able to compose real-time pipelines or batch pipelines just by sort of having some Lego building blocks written on a canvas. And because all the components have the telemetry built in, we don't need to write any code for monitoring, whether it's experiment tracking or real-time monitoring, and so on. And we can close the feedback loop of things like retraining or examining the production data set for for tuning our model further. So essentially with MLRun, which is again an open source project, there are four major elements to it. The first one, all of it is running on this sort of serverless processing engine architecture, which is again auto-scaling. It saves lots of money because it can run on spot instances, etc. But it has four main pillars. The first one is the feature store. And what's unique about ML feature store is not just a catalog like some of the other feature stores in the industry. It essentially allows you to compose analytical pipelines, which will automatically translate into real-time workloads or batch workloads or both without doing any extra work. I don't have time to show you a full demo, but also have links in the presentation to three different demos. You have the real-time serving pipeline, which is essentially a way for you to compose a DAG, a graph of activities. Those activities could be data processing, could be validations, model serving, ensembles, and so on. You have a library of components that you can choose from, and you could compose a pipeline, especially when you're dealing with apps like NLP, et cetera. The pipelines, the real-time pipelines could be very complex. There's a great presentation by one of our customers on document processing using that technology. We can send a link later. And then once you've done the pipeline, you have the aspects of monitoring and retraining. And last but not least is the full orchestration, the full automation of all of this workflow. And I'll try and dive into each one of those in a quick few quick slides. So feature store, what is really a feature store? Feature store is essentially the way for us to collect data from all sorts of sources. Sources are not necessarily static. They could be a bucket in S3 or Azure or something like that, but it could also be snowflakes or BigQuery or a stream using Kafka or Kinesis or an HTTP endpoint or a video feed, etc. So the first thing we need to do is connect to those sources of data. Then we need to apply a bunch of transformations to take that data and make it something useful, group and join, etc. And finally, those features are getting cataloged, so we can just pick and choose and train or serve based on those features. Now, the serving part in a feature store usually has two or more material views. Essentially, it could work with interactive workloads. So guys in notebooks or external exploration tools can just go and play around with the data and see and visualize and build some insights. You want to do training, so there is a mechanism where you can say, give me a snapshot of the production data, on this time window, etc. And you could just run training from that. If you want to do serving, there's like a real-time API where you can, throw in some entities like a user ID. You get the entire feature vector within a millisecond, give or take. And there's also the monitoring aspect, which uses the feature store for storing statistical information about every feature, and based on that, making some comparisons and analysis, but also writing production data back into the feature store is what we call production feature sets, and allows us to do things like explainability or retraining or post-mortem analysis and so on. So this is the general idea of how feature store works. And in MLRun, you have a great feature store. This is the only one which is not limited to structured data. So you can build essentially all sorts of analysis, also for NLP, for visual, for video streaming. We have examples for all of those. The great presentation from IHS also talks about composite transformation, essentially taking documents with PDF, with images, text, tables, numeric data, and making predictions based on all of that. So this is a great feature. The other thing that also the feature store is using that engine under the hood is the real-time pipeline composition. So essentially, you can just go and draw in your Jupyter or in Python. You can just draw a real-time pipeline. You can test that real-time pipeline, few lines of code, validate that it actually works, and you want to make it run, just say deploy, and you have a full real-time pipeline deployed, including auto-scaling and rolling upgrades and canaries. All of that is built into the system, so you don't need to develop. And it's very important to understand that deploying is not about deploying a model. A lot of people I speak to say, oh, you know what, I'm just creating a model, I'm creating an endpoint. And I'm saying, yes, but eventually the real world data doesn't arrive as a vector. The real world data arrives as a picture, as a JSON message. Who takes that JSON message and breaks it into, sort of validates it and extracts the features from a feature store and runs it against the models and maybe does post-processing and writes the results to a database or triggers some activity. Who does that? They say, you know what, this is the software guys on the other side of the room, and there's not enough software guys. We all know the situation today in hiring people. So if we can automate this flow and not necessarily break it to silos of these are the software guys building their software with their versions, these are the data scientist guys doing their stuff with their models, and these are the data engineering guys that build, window aggregations, etc. Each one will work by himself. There's no common versioning. There's no common deployment mechanism. You're going to waste a lot of energy. If you can build all of that into a simple flow and deploy it as an application, you're going to save a lot of energy and you can deploy a lot more new applications. And the last portion here before the CI is essentially the model monitoring. All those things have built-in telemetry, metrics, requests per second, but also higher level metrics around sort of drift analysis and model behavior analysis. And we're adding more and more things around business metric analysis and so on. The last part is really about how do we automate this entire flow that we want to have data or data snapshots. We want to run training. We want to produce models, but not just models, as we said. We want to build application pipelines, and those application pipelines need to also be tested, not just building the model. We want to build application pipeline in a test cluster, see that it actually works, and then create a version. And we'll talk about the version promotion flow in a second. So this is what we've done is a fully automated flow, plugs into almost any CI system, GitHub, Actions, GitLab, Jenkins, Kubeflow, and so on. And you can just trigger this flow. You can draw the flow, you can define it, you can trigger it from code changes, API calls, data changes, and so on. And this will run a full workflow. You can, in this workflow, you can combine marketplace functions. So you don't really need to build your own training. You could use an AutoML marketplace function, a data analytics marketplace function, or external service like Azure ML or SageMaker as part of your automation pipeline. Each one of the steps in the pipeline is auto-scaling. That means that if I need to train on a dozen containers with GPUs, it's automatic, and you could just specify the ranges of resources that you need to use, and it will essentially do that. Everything gets tracked and versioned. There's consistent versioning across all objects in the system, whether it's data or experiments or jobs or features, etc. One of the things that we've added recently, we've seen other frameworks adopting the concept of auto logging. We took it to the next level, essentially, because again, in the way that we see that, it's not just about tracking experiments. It's also about a lot of the things that we focus on is automation, is the orchestration. And so when we did serve what we call auto MLOps, it's not just about tracking the experiments and the models. Essentially, we'll do all of that for you to log the artifacts, the metrics based on every framework. It will save the models. You can choose what's the format you want to save it, Onyx, JSON, etc. But it will also do the provisioning things. It will automatically add the auto-scaling hooks. It will handle checkpoints. It will write to third-party open source frameworks like TensorBoard. It will add GPU optimization layer, etc. So that means that from the data science perspective, all he needs to do is just add one line to his code, and all the rest of this wonderful stuff is going to happen automatically for you. And the other thing that we want is we want it to be an open system. So if you're running in Jupyter, and this is where you want to see the progress of your workflow, great. But on the other end, if I'm running as a pull request within the context of a pull request in GitHub, I want to track the results in GitHub, or maybe in Kubeflow, or maybe TensorBoard if I'm a fan of deep learning, or maybe I just so much like notifications on Slack. So we essentially plug into all systems. You can run the workflows in MLRun and essentially view the progress in every other system. Now, a lot of people ask me, and we did some webinar last week about it, how do customers really do the staging from development to production? I took a serve from some of our customers, the way that we're doing it together with them, and understand sort of the overall development flow. So the first thing that people usually do is create a feature branch in Git. And when they create a feature branch, they don't necessarily run the pipeline in the CI. They may want to run it locally. whether it's on their local computer resources or on a cluster in an interactive fashion. So the first step would be to commit to create a branch. And here we need to run three things, not just the training. We need to prepare the data. We need to run the training and validation and testing of the model that we created. We need to also deploy that model as part of an application context, as we mentioned before, maybe a slightly simpler application context, and test that what we've deployed actually works. Because maybe the training works and the model works in a synthetic environment. When it's containerized, we forgot about a package, the message format is slightly different, and so on. So we need to do that testing. At a certain point, the developer wants to merge his changes into a development branch. So he creates a pull request. The pull request will trigger CI things like Black and Flake 8 and so on, static analysis of your code, unit testing that runs within the CI, like GitHub Actions. Once this is done, it can trigger a workflow. The workflow now requires lots of resources. You don't want to do the development testing on a small CSV file. You may want to build it on a much larger data set and automate and use hyperparameter tuning and things like that to run at scale. So essentially, the CI system will trigger an MRun workflow that does all this work. The results will go back into the workflow we've seen in the previous snapshots. So in the pull request, you can actually see all the results with hyperlinks into the full detailed reports. Once you feel it's okay, you can just approve and merge and do additional testing on the development cluster with more sort of regression tests. At a certain point in time, you want to create a full version, then essentially you need to create a pull request into master. There is sort of business validation, essentially taking that pipeline and running it alongside the previous version pipeline. Maybe 10% of the data will go to the new pipeline. And again, I'm saying pipeline, not model, because we want to run the full flow from gathering data to conducting some actions. When we approve, then essentially we create a tag of the release and it rolls into production. So these are the more advanced users that wants to see everything fully automated. This is the traditional flow. Now we have a few examples. I won't be able to show you demo, but I have hyperlinks to the actual full demos and code for those projects. So just to see, there are three examples here. One is more machine learning oriented. This is like a real-time fraud prediction. It's done in like 3 notebooks, the entire project end to end. The first part is about creating features, doing all sorts of Windows aggregations, and in the feature store on live transaction data, joining it with customer activities and so on, and storing all of that into a feature step, into the feature store, showing how you can do interactive exploration, then triggering automated CI workflows to feature optimize, essentially do auto feature selection, AutoML, and a few other things in the pipeline. Finally, deploying real-time pipeline for the fraud detection using the Nucleo real-time serverless engine, and doing the model monitoring, which feeds back into the feature store. Again, the full demo and notebooks are found in this link. Another cool demo is on NLP, essentially taking news articles, analyzing them, and indexing them. Again, I won't go into all of that because we don't have a lot of time, but you can just go into that link and see the full demo. There are more advanced. There's another cool demo that we're sort of rewriting that takes Yahoo news and Yahoo ticker feeds and based on that build model on the combined sort of what we call composite AI, sort of real-time time series data alongside the NLP data. Another example is with sort of deep learning. Think about a factory that generates images and you want to identify defects. All this stuff goes into an object store. Then you have the development pipeline, which may consist of distributed training using GPUs and Horvath. In MLRun, you don't need to think about all of that. You just throw in your TensorFlow code. We know how to map it to Horvath. We know how to scale it out, add GPUs and hyperparameters to it. So you run this. Your workflow also does things like validation and testing, model compression and optimization using Onyx, and deploying the pipeline. But deploying a pipeline, again, is not a model endpoint. it's essentially, this is the production pipeline in the dynamo. So every time a new image arrives, goes through Kafka, we need to fetch the image from the object store because this is like just the URL. We need to do processing on the images. Then we classify. We may do some additional processing after the classification and push results to a message queue. The nice thing about the real-time pipelines, you can actually divide them to different containers. You could say all those things run in one container. Classification runs with a different container with GPUs. And the last, sort of the suffix, runs on a third container. This allows you to reduce significant costs because only the thing that requires GPU will run on the GPU. All the rest of the steps will run on other things. And this is an asynchronous pipeline, real time with streaming. So it's very high performance, very high concurrency. So you can see those 3 demos and find more demos. You can contact me on LinkedIn, Twitter. I'm very happy to talk to people about those things. There are lots of lectures that we've done as part of our MLOps live webinar series about many of those different topics with guests. So feel free to join and learn more.